we are going to learn about the linear congruence, what they are, why they matter, and how to solve them. Starting with what is a linear congruence? A linear congruence is an equation of this form where a, b are the integers, m is positive integer, x is variable. It means a congruence that involves a variable with the power 1 that is called as the linear congruence. In simple words, it means when you multiply a by some integer x and divide by m, the remainder is b. Now, why should we care about linear congruence? Because they help in solving where remainder matters, like in a cryptography, coding theory, scheduling, and the number puzzle. The point is, if that matters, then how to solve them? We find the value of x that makes this equation true. Means when you multiply by x, divide by m, and the remainder is b. Let's understand with the help of examples. Consider the first case. If 3x is congruent to 0 mod 3, then find x. To answer this, let's test value for the x. When x is 0, here we have 3 into 0, that is equal to 0 mod 3. Is this is true? Yes, because 3 into 0 is 0, or we can say that 0 is congruent to 0 mod 3. Both sides the remainders are same, hence this congruency is true. When x is equal to 1, 3 into 1 is congruent to 0 mod 3. Yes. How? Because 3 into 3 is 3, and when it is divided by 3, remainder is 0. So again this is true. When x is equal to 2, whether this congruency holds, 3 into 2 is congruent to 0 mod 3. Is the statement is true or not? 3 into 2 is 6. 6 when divided by 3, remainder is 0, and even we need 0 here. So again this is true. Now we can say that x can be any integer. Taking one more example. If 4x is congruent to 1 mod 5, find x. In this case, we need to find the x such that when it is multiplied by 4 and divided by 5, remainder is 1. Let's test possible values of x. If we substitute x is equal to 0, what we have? 4 into 0. That is equal to 0. When divided by 5, is the remainder is 1? No. So this is not congruent to 1 mod 5. So in this case, we cannot say that x is equal to 0 is a solution. What about x is equal to 1? 4 into 1. That is equal to 4. Is congruent to 1? Whether the remainder is same in both the cases? No. It means x is equal to 1 is not the solution of this linear congruence. For x is equal to 2, 4 into 2, that is equal to 8. 8 when divided by 5, remainder is 3, not 1. So it means x is equal to 2 is not the solution of this linear congruence. For x is equal to 3, 4 into 3, that is 12. 12 when divided by 5, remainder is 2. And that is not congruent to 1 because both sides remainder is not is equal to 1. So we can say that these two numbers are not congruent with respect to mod 5. When x is equal to 4, 4 into 4, that is 16. 16 when divided by 5, remainder is 1. So 1 is congruent to 1 mod 5, as we need 1 here. So that is applicable in this case. So we can say that x is equal to 4 is the solution of linear congruence. Taking one more example, if 4x is congruent to 3 mod 6, find x. In this case, check whether x is equal to 0 is a solution or not. 4 into 0, that is 0, and that is not congruent to 3 mod 6 because we need the remainder as a 3 in this case. So it is incorrect. X is equal to 1. 4 into 1. This is equal to 4. 4 when divided by 6, remainder is again 4 because 4 is less than 6. So this is can never be congruent to 3 mod 6. 4x is equal to 2. 4 into 2, 8. 8 when divided by 6, remainder we have 2. This is not congruent to 3 mod 6. X is equal to 3. 4 into 3, that is the 12. When divided by 6, remainder is 0. So again that is not congruent to 3 mod 6. X is equal to 4. 4 into 4, 16. 16 when divided by 6, remainder is 4. So this can never be a congruent to 3 mod 6. X is equal to 5. 4 into 5, that is 20. 20 when divided by 6, remainder is 2. So that can never be congruent to 3 mod 6. Now think, here we have the repetition of the remainder 0, 4, 2, 0, 4, 2. Again we will get a 0, 4, 2 for the next integers. So we can notice something, no value gives 3 as the remainder. It means there is a no solution in this case. In these three examples we just solved, we easily tried out find possible values by hand and checked if solution exists or not. But there is an important question, if the numbers are very large, do we keep checking values manually? If we are working with the manual procedure, it would take a lot of time, and if a solution does not exist, it would be completely waste of effort. Don't worry, there's a result from where we can predict in advance whether the solution exists or not and how many solutions we would expect in a particular range. The theorem states that if we have a linear congruence of this form, then it has a solution if and only if D divides D, where D is a GCD of A and M. What we need to do, starting with the given linear equation, we just need to calculate greatest common divisor of A and M. Find the GCD of A and M and name it as a D. And you just need to check whether that GCD divides B or not. If yes, solution exists. If not, no solution exists. Moreover, it has a D solution in Zm. Now what is a Zm? Zm is collection of positive integers less than m, means up to m minus 1. Also note that if any one solution exists and if we have specified any one solution, the other solution can easily calculate it with the help of this expression. Now back to the previous three examples. In the first case, we have taken this equation. 3x is congruent to 0 mod 3. Let's apply that theorem here. Check whether the solution exists in this case by the theorem. According to theorem, we just need to find the GCD of these two numbers. So what is the common divisor of 3 and 3? That is 3. Now check whether 3 divides 0. That is 3 divides 0? It means 0 by 3. Is this is equal to integer? Yes. It means yes, 3 divides 0. But 0 does not divide 3. That means 3 by 0 is not defined. As 3 divides 0, it means it has a solution. Now, how many solutions we have? That is equal to the GCD. We have 3 solutions in Z3. Now, what is a Z3? That is integers less than 3, and that is a positive integer 0, 1, 2, or we can say that a possible remainders when any integer is divided by 3, that is 0, 1, 2. We have 3 solutions in this case and we have 3 numbers in this set. It means all these 3 numbers are the solution of this linear congruence. And even recently we have evaluated this one. In the second case, when we have 4x is congruent to 1 mod 5, find x. Check it whether it has a solution or a not. What we need to do, we need to calculate the GCD of 4 and 5. So what is the GCD of 4 and 5? What is the common between 4 and 5? That is 1. Now, is GCD divides this number? Whether 1 divides 1? Yes. So, it means it has a solution. Moreover, it has a one solution in Z5. Z5 means from 0, 1, 2, 3, 4, we will get only one value of the x in the set. And that we have calculated as the 4. Whereas for the case number 3, 4x is congruent to 3 mod 6. Find x. Now before finding x, check it whether it has a solution or not. What is the GCD of 4 and 6? That is 2. Now check whether 2 divides 3. No. As 2 does not divide 3, it means it has a no solution in Z6. Or we can say that it has a no solution in all integer set. With the help of theorem, we can see that in the third case, there is no need to waste our time. First, we just need to check whether the solution exists. If yes, then we will find out. Otherwise, by the theorem, we can directly say that there exists no solution. Taking one more example, here we need to find the solution of this linear congruence. Moreover, we need to find all these solutions. Now check it whether this linear congruence has a solution. For that, we will compare this linear congruence with the original one, that is AX is congruent to B mod M. According to this, A is equal to 18, B is equal to 30, and M is equal to 42. The first step is check GCD of A and M. What is that? So how to find the GCD of 18 and 42? What we are doing, we can use the Euclidean algorithm or we can do the prime factorization. What is the prime factorization of 42? 42 is substituted as 2 into 21. 21 is substituted as 3 into 7. Whereas 18 is substituted as 2 into 9 and 9 is substituted as 3 into 3. Common multiples are 2 and 3. So GCD of 18 and 42 is equal to 2 into 3, that is equal to 6. So this is the value of D. In the next step, check whether D divides B, means whether 6 divides 30, or we can say that 30 by 6 is equal to some integer or not. Yes, that is equal to 5. So as D divides B, we can conclude that linear congruence has 6 solutions in Z42. Z42 is from 0, 1, 2 up to 41. Now, how to find the solution in this case? First, we will go with the hit and trial. So, by hit and trial, find one solution. Is x is equal to 0 is the solution of this one or not? 18 into 0, that is equal to 0. Is that is congruent to 30? No. So, it means it is not the solution. X is equal to 1. 18 into 1, that is equal to 18. As it is not divided by 42, so remainder is 18 and that is not congruent to 30 mod 42. X is equal to 2. 18 into 2, this is equal to 36. Is 36 is divided by 42? No, it means 36 act as the remainder and that is not is equal to the remainder 30. So it means x is equal to 2 is not the solution of this. Now x is equal to 3. 18 into 3. This is equal to 54. 54 is greater than 42. So we can divide 54 by 42 and in this case the remainder is 12. And that is not congruent to 30 mod 42. It means x is equal to 3 is not the solution. Take x is equal to 4. 18 into 4. That is equal to 72. 72 when divided by 42. What is the remainder? So in this case the remainder is equal to 30. So it means this can be written as congruent to 30. And even we need 30 here. So we can write congruent to 30 mod 42. So first solution by hit and trial we are getting as x naught is equal to 4. Now the rest of the solution is easy to evaluate. What we need to do, we will find m by d. What is the m by d in this case? That is the 42 by 6. This is equal to 7. After that we will use that expression. The expression is next solutions are written in the form of x naught plus m by d into t. From here substitute t is equal to 1. Because when we have t is equal to 0, that is equal to 4. For t is equal to 1, we will get x1, that is equal to 4 plus 7 into 1. This is equal to 11. So the next solution we have 11. Its next solution x2, that is 4 plus 7 into 2. We can also simplify this. This is 4 plus 7 into t. That is equal to 18. Similarly, evaluate x3, that is equal to 4 plus 7 into 3, 25. x4 is equal to 32. x5 is equal to 39. If we calculate x6, that is equal to 46. And this number exceeds from this set. As we need a 6 solution and 6 unique solution in Z42 are 4, 11, 18, 25, 32 and 39. Once we have the unique solution in a Z42, we can write all other solutions are of the form 4 plus 42 into k as we are dividing by 42 or 11 plus 42k or 18 plus 42k or 25 plus 42k, 32 plus 42k, 39 plus 42k, where k is any integer. Now why we are taking 42k? Because when we have 46, that can be represented in this form. Because that can be written as 4 plus 42 into 1. If you find x7, that is equal to 51. And when you divide by 42, the remainder is 11. It means 51 solution can be expressed by this form. So all the integer either of this form or this or any of these form that are the solution of given linear congruence.